I thought I'd chosen a controversial topic, but I think my controversy has been rather blown out of the water this morning. Well, I'm very grateful to the invitation to come and speak today at the conference, and it's so pleasant that you arranged for such British weather to welcome me. And I'm also very grateful to Safety Equipment Australia for sponsoring the attendance at the conference for me. You know, in Europe we have had lots of problems in trying to bring forward new binding occupational exposure limits, and the whole process of developing new regulations, particularly in relation to carcinogens, has been fraught with problems. And we've been trying to update these regulations in Europe for more than a decade. And still, the process goes on, although we are coming hopefully towards the end of this. And we'll have new binding limits for a smallish number of substances that will go into the directive. But throughout all this time, the process of industry has gone on, and people have been getting on with their lives, and businesses have been working away. And the world hasn't fallen apart without these new limit values in place. So what's the point of occupational exposure limits? I mean, do we really need them? And if I can get the technology to work, yes, thank you. What I want to do is to talk a little bit today about occupational exposure limits and how we've used them in occupational hygiene as part of a fundamental paradigm for operation. I'll go through some of the developments of occupational exposure limits and how they've moved on from being advisory limits towards things which are embedded within regulation and become something which we need to try and comply with, and this compliance agenda that we're so aware of. And then I'll try to outline where I think some of the crises occurring with the limit values process, and to see what problems we are facing, and then go on and try and be a little bit positive at the end of the talk and try and suggest some further developments which will be something to think about, something which might help us try to move the paradigm of occupational hygiene forward for the 21st century. So lead's something I'm interested in, I've been interested in for some time, and lead poisoning has been known for many centuries. The Greeks and Romans in ancient times used to add lead to food and wine as a preservative and an improver, and the consequences of that were that lead poisoning was relatively commonplace in society. And in the 2nd century BC, Lysander wrote eloquently about lead poisoning, although he didn't call it that, but he was describing colic and paralysis, which clearly was caused by exposure to lead. So something that we've known about for a long time. And at the beginning of the last century, it was a real problem for people in society still. And every year in Britain, at the turn of last century, there were about 1,000 people diagnosed with lead poisoning. And that clearly was something that was of great concern, and the physicians at the time were, well, they knew what the problem was, and they knew how to solve the problem. This is a book that was published in just 1902 called Dangerous Trades, written by Thomas Oliver, a physician from Newcastle in the north of England. And in this treatise, which is 400 or 500 pages, about a fifth of it is devoted to lead and the problems of lead and trying to alleviate these problems. And one of the things he highlights as a sort of narrative story is a lead works in the north of England, where women are employed in the manufacture of white lead. And he talks about women who work in the stove area of the process, which is shown in the in the diagram on the slide at the moment, where the women had to take the white lead in bowls and carry them from one part of the plant to the other for drying. And he recounts that he's known young women who die from lead poisoning within 3 months of starting work in this factory when they've been working in this area. And it was very interesting for me, that this very old image shows the woman wearing some sort of crude face mask to try and protect against this problem. And the physicians and the regulators at the time solved the problem quite quickly, because they banned women from working in this part of the factory and solved that particular problem. Well, something happened over the next decade, and this diagram shows the number of reported cases of lead poisoning in Britain from 1900 up to 2000. And you can see that year on year there's a general downward trend of the number of reported cases. And it follows an exponential curve, so it's clearly something that's gathering momentum over time. And it's quite interesting that the trend doesn't seem to be very much influenced by major events, world wars, introduction of new regulations, or anything else much. It seems to be something which is intrinsic to the way that society and industry is working. The only small blip up, which happens in the 1960s, is almost certainly nothing to do with the industry, and it's all to do with the diagnosis of lead poisoning. Because around this time, the use of blood lead in the diagnosis became more common. And of course, the increased sensitivity of diagnosis was apparent. Well, by the time we got around to introducing the control of lead at work regulations in 1980, well, the problem had more or less been solved. And clearly, the regulations themselves didn't have any real further impact. And throughout this time, we didn't have any formal exposure limits, and yet we see improvements year on year in terms of the exposure that people were getting to lead. There was some suggestions about what might be acceptable, and this is taken from a factory department memorandum from the Home Office talking about lead poisoning, and the particular text that I want to highlight says, somewhere about 2 milligrams is the lowest daily dose which inhaled as a fume or dust may, in the course of years, set up chronic plumbism. So in other words, they knew that there was some sort of threshold. If you could get below this 2 milligrams per day daily dose, then you could start to think about protecting workers. And they actually were able to put this in the sort of context of the concentration that the workers might be exposed to, because they go on and talk about inhaling about 10 cubic meters per day of air, per day at work of air. And then, so you can, doesn't take a genius to figure out what the recommended exposure limit was for lead at this time. It was 0.2 milligrams per cubic meter of air in 1921. Now, we probably didn't have the hygienists and the technology around to measure with any great accuracy at this time, but we certainly knew what the target we should be dealing with was. By the 1940s, we have the introduction of the first systematic list of occupational exposure limits from the American Conference of Governmental Industrial Hygienists. 144, what they originally called maximum allowable concentrations, and eventually transitioning into the name of threshold limit values. Well, in the 1940s list of limit values, the maximum allowable concentration for lead was 0.15 milligrams per cubic meter. Very similar to the value that we saw recommended for the 1920s. Nothing much had changed in those 20-odd years. Well, the whole process of threshold limit values and how they were developed continued, and by the 1970s, many countries had adopted the TLV list as the basis for advising about what was the best way forward. And in the UK, we first of all republished the list of TLVs to advise industry and hygienists about what was an acceptable level of exposure. And then we eventually more formalized the limits and started to develop our own limits in a similar sort of fashion, intended to be more representative of the situation that prevailed in Britain. Well, it was quite interesting to note that William Yant, who was the first president of the American Industrial Hygiene Association, really made a strong case for limit values being advisory. He said that as soon as you start to have limits which are mandatory, then they become, the standard, and then anything below that's really just completely acceptable, and we shouldn't worry about it. And and that kind of philosophy, where you just have to meet the standard and that's it, is something that we have recognized and we've paid lip service to over the years, saying we should get as far below the limit as possible and so on. But the tendency to see these limits as just the standard to be achieved, I think, is not that uncommon. I have to keep looking around. I apologize for this because the screen down here doesn't actually show the slide that is up on your screen, so it's rather confusing for me. Anyway, the whole development of occupational hygiene is, I think, based around limit values. We, as hygienists, we go out and we measure or assess the exposure, and then we, thank you. Then we assume that there's some relationship between the exposure and the risk. And we can't easily get to risk as hygienists. We don't really have this ability to look at early signs of disease or anything like that. We're focused on, if we can control the exposure, then as a consequence we'll be able to control the risk. And to set some sort of boundary between what's considered acceptable and unacceptable, we use the concept of an occupational exposure limit. It's really the center of our whole paradigm. This is how we kind of operate, and it's gained that sort of high status in our profession. So I think part of the problem has been when we make the transition away from using limits in a supportive way for the profession to operate, and we start to incorporate these into legislation. So in Europe, we have Chemical Agents Directive, and we have the Carcinogens and Mutagens Directives, which relate to the operation of industry in terms of these types of agent. And the basis for exposure limits is built into these pieces of legislation, so that you can see, as it says here, that particularly in the case of carcinogens, exposure shall not exceed the limit value of a carcinogen as set out in Annex 3. And the same for Chemical Agents Directives, that there's an obligation on employers where they measure exposures in excess of the limit value to take immediate steps to remedy the situation, to try and reduce the exposure. So now we have the situation where we are moving into the area where we need to assess compliance. We need to know, do we comply with the law? Are our exposures below the limit? And in Europe, we have a standard documentation which has been developed to allow us to measure and assess exposure, and the latest iteration of this standard will make recommendations about how best to assess compliance with limit values. This is EN 689, which will be published in the coming year. So we as hygienists, I think, understand the role of occupational exposure limits, and we probably accept their incorporation into law. But what about other people? Well, in the 1990s, the UK Health and Safety Executive carried out extensive consumer research, asking companies and employees what they knew about the health and safety systems. In particular, one of the questions asked was in relation to, or some of the questions asked were in relation to the perception and the way they used occupational exposure limits. And in the report from this, HSE say that most employers relied heavily on other things other than exposure limits. They relied on support from their suppliers, the personal experience, and they relied much less on official support. And the very understanding and use of occupational exposure limits reported in the survey calls for reappraisal of OELs. This is in the 1990s, where HSE is saying, we don't think these people really understand what they're supposed to be doing. You guys do, but the employers are really rather mystified by this. And this whole report and the consequences of the survey led to the development of the control banding approach and to the whole idea of cost essentials and providing more soft advice to companies about how they should achieve a safe work environment rather than understanding the technicalities of using measurements of exposure or assessments of exposure in occupational exposure limits to decide on the whole best approach to manage. Well, there are other problems apparent with occupational exposure limits, and the whole system is a rather chaotic process, I think. Compliance focuses on attention to the worst situations. So to achieve compliance, you don't need to worry about the mass of people in your workplace. You really just need to focus on those critical points where the exposure is highest. So it tends to focus efforts on control in a small area of the plant or the operation where you need to achieve best practice. As I've indicated in the UK and Europe, the whole process of updating limit values becomes mired in the whole legal arguments. And the standoff in Europe is basically between all the parties who are involved, trying to get something which everyone can sign up to, the employers, the employees, and the governments involved in the whole process. And it seems almost impossible to get consensus. In many cases, there's limited or insufficient information from epidemiology or toxicology to set an appropriate limit. Sometimes employers just don't understand how to measure exposure, and then sometimes you're in situations where the current exposures are much higher than the target level that you would want to achieve to prevent health. And a good example of that is diesel exhaust particulate, where the only standards that exist in Europe are something like 10 times higher than the level that you would really want to achieve in terms of preventing cancer from exposure to diesel engine exhaust. So, there's a whole host of problems behind OELs that make it difficult to see that this is the right thing to do. And yet, as I've said, it's the whole basis on which our profession is organized. We really need to ask the question, do we need to have occupational exposure limits? What's the point of them? And do they help compliance? And I think the answer to that is no. They don't really help protect people's health in terms of complying with the law. In general, what we need to do is to try and improve the whole of the work environment. Now, there's good evidence to suggest that whether or not you've got exposure limits, whether you've got legislation, that things get better over time. Something is working in this whole process. And this graph shows data from a report that we published in 2007, where we reviewed all the available literature on temporal trends in exposure. And these data are just for the dusts, but we have similar data for gases and vapors and for fibrous dusts. And in this case, there were 38 situations where we were able to get data that was informative. And in all but one of these cases, the exposures went down over time. And in something like 60% of them, there was a statistically significant reduction in exposure over time. And typically, the change in exposure was somewhere between 5 and 10% per annum. So every year, the average exposure in these situations was dropping by somewhere between 5 and 10%. And over a decade, that's a substantial reduction in exposure. This is not driven by exposure limits. This is not driven by legislation. This is driven by something else. And it's very similar to the graph that I showed earlier in relation to lead poisonings. It's showing the same kind of year-on-year reduction in the risk in these situations. And the logical argument is to say, well, if it's not us who are doing this, then what is the factor that's causing decline in exposure? And it must be something more intrinsic to the way industry operates. And it's something to do, I think, with continual sort of small improvements that are made in plants to improve, probably to improve the efficiency of production rather than to improve the safety. And as a byproduct of these changes, we probably get lower exposures. You buy new equipment, it's less dusty in its processing, it's less noisy. You know, the benefits are side benefits for us. And that led me to think about perhaps there's a better way forward for us in the future, that we maybe need to think about a process whereby we're not trying to comply with a set limit, but what we're trying to do is to seek continual improvement in the exposures that we measure. And this, I think, it's a real important change, because we're no longer saying it's good enough to just deal with the dirtiest parts of the process, but we're trying to say we want to try and reduce the exposure for everyone in the workplace on average. So we want to focus on a systemic change in the total exposure. And this idea of Kaizen, which is a Japanese word for continual improvement, which they've developed into a culture for industry, involves a collaborative venture between employers and employees to try and develop technologies which are better than the previous iteration that was being used. And Japanese technology has been improving on this kind of basis for some time. So if we think about this new approach, then OELs become pointless, or, well, after I wrote that down, I thought, okay, maybe almost pointless, because I think there is, as I'll show you, I think some still purpose behind it. But if we change the emphasis or change the paradigm of occupational hygiene so that we don't try to seek compliance, but we try to work for continual improvement, then we will be going with the flow. This is what industry is doing anyway. This is the process by which they're going. And if we could accelerate the rate of change by our intervention, in other words, to move from, say, 5 to 10% per annum to 10 to 20% per annum, the benefits to the whole workforce would be huge. This side benefit of reducing exposure to everyone in the workplace would be a real plus. So now, if you want to adopt this, you no longer need to think about compliance testing, but you think about reporting annual percentage reductions in exposure, and you could do that by company, by industry sector, by whatever. And the public declaration of this is the way that you get some sort of external check on it. So in other words, as an industry, you would be declaring to the outside world the progress you've been making or not. And that would be the point. So the almost bit then in this title is really that I think you do need something to address the issue about the criminals in our society who neglect to do what is the right thing and flagrantly expose people to high levels. So you still need exposure limits in place for those sorts of things, but you can see it as being the backstop rather than the mainstay of what we do. Now, there are some good examples of where this is being tried out in Europe, and perhaps the best is this scheme called NEPSI, which is a network for silica in Europe, which has been formed by the employers and the trade unions in Europe as a joint venture. And it's done under the approval of the European Commission, so it has official sanction, and it provides a scheme where the employers commit to certain things. They commit to provide information, training, and so on to workers, but they also commit to carry out health surveillance and also to monitor the exposure of the workers and to use this information as some way of seeking further improvement. You know, the one thing that disappoints me about NEPSI is that they haven't published their data. So they make the measurements, they share them amongst themselves and with the official regulator, but they don't publish them widely. I think that's a mistake. But the Industrial Minerals Association, who are part of NEPSI and perhaps one of the largest groups, trade groups within NEPSI, have published their data, and they show exactly the same sort of trends we've been talking about, a downward movement in exposure year on year, which is broadly in the lines of sort of 10% per annum. And that data, I hope, will finally be published in the peer review literature next year. There's also some information from Finland about the effects of NEPSI, where the Finnish Institute for Occupational Health has a relatively large database of measurements that were made in silica industries which were participating in the NEPSI scheme. And they published this information showing that when NEPSI was introduced, it coincided with a decline, a fairly substantial decline in the average exposure amongst these industry groups. And while you can't say it's directly related to the introduction of NEPSI, I think it's good circumstantial evidence for the effectiveness of the scheme. The other system that I wanted to highlight is from the German Bauer regulator. So these are the official regulators for health and safety in Germany. And they've published this scheme in relation to carcinogens, and they set out 2 limit values now. So they still have an occupational exposure limit in the process, but the idea here is to set acceptable and tolerable risks, where the acceptable is the target that we should be trying to achieve, and the tolerable is the legally enforceable backstop. So in other words, it gives people a target. No longer do you have to say, you know, that we're in compliance, but you can say, and we're heading towards acceptable levels, and you can discuss this in relation to the progress of the organizations. And then their scheme, excuse me, in their scheme they specify that the tolerable concentration should be a concentration that gives rise to a lifetime risk of cancer of 4 in 1,000. And they say that roughly corresponds to the lung cancer risk for a non-smoker who doesn't have any exposure to occupational carcinogens. So it's something which is broadly related to work exposure. And they, for acceptable risk, they originally set it out as being 4 in 10,000 lifetime risk of cancer, and they are just about to reduce that to 4 in 100,000. And what they say is that this would correspond to environmental risk. So they're advocating that in workplaces we should be driving down exposures to try and correspond to the kind of environmental cancer risks that are prevalent more widely. This is a big shift, and it doesn't necessarily involve the sort of continuous improvement paradigm that I've been talking about, but it's a framework that could be a transition for that kind of approach, and it would build into it this legal backstop that I've been talking about. I compared some of the Bauer proposed limits with the British workplace exposure limits, and this graph shows that comparison. Each line, the vertical red lines, represents the range from tolerable to acceptable that the Bauer have recommended, and they're set across in relation to the appropriate workplace exposure limit in the UK. So you see for asbestos, the workplace exposure limit in the UK is 0.1, and Bauer recommends their tolerable limit to be 0.1 and their acceptable to be 0.01 fibers per milliliter. Well, the first thing to note is that almost all of the limits are below the current British workplace exposure limits, and the acceptable limits are somewhere between 1 and 2 orders of magnitude below the British limits. So they are substantially challenging where we should be heading in terms of exposures in the workplace. So in conclusion then, I've tried to make the case that occupational exposure limits are necessary but not sufficient to protect worker health, that we need to have some legal backstop to protect workers from flagrant disregard for the conditions. But in the main, this compliance strategy is never going to be successful in reducing the exposure for the whole workforce. We need to recognize that things are changing in the workplace all the time anyway, and improving in most cases all the time. And this results in a decrease in exposure. And if we go with the flow and try to build on that trend and try to seek some enhanced continuous improvement, then that will, I think, be an alternative way to frame our practice and our approaches. If you're going to do this, then the way to monitor how well we're doing is by going out and measuring exposure in the workplace and then reporting those results widely so that people can understand the changes that are being made. Well, thank you very much. Hopefully be able to answer your questions.